The Phys package enables controller-based physics interaction with Unity's rigid body objects. You can grab, throw, push, pull, shove, or otherwise manipulate objects using your VR controllers and a set of virtual hands. As a first step, select a controller and enable physics interaction by clicking Add Module, selecting an input manager and grab provider, and hitting Update. There are 3 different grab providers to choose from. The more complex ones come at a minor cost in performance but are significantly more powerful. By default, every grab provider comes pre-configured with a grab zone and a grab spot. The grab spot represents the location that the grabbed object is anchored to, and the grab zone represents the area that objects can be grabbed out of. In the case of a grabbable volume finder, when the trigger button is pressed, the grabbable volume finder will look for grabbable objects inside of this volume, select the one that is closest to the grab spot, and perform the grab on it. If you wish to select objects in a different way, for instance through a point array, you can make your own grabbable finders by inheriting from the grabbable finder object and replacing this component. The basic grab provider is, as the name suggests, the most basic one. It grabs objects by moving the center or pivot of the object towards the grab point. This provider is sufficient for many use cases in which you only want simple interaction possibilities and mostly use smaller, preferably spherical objects. For instance, drawing balls from an urn. The offset grab provider grabs objects at an offset from their pivot, meaning you can grab objects at the closest location to the grab points rather than directly at their center. Additionally, the offset grab provider works with the hand interactor module. When using a hand interactor, you will be shown a virtual hand and its fingers will automatically adapt themselves to a grabbed object's surface. The advanced offset grab provider is mostly identical to the offset grab provider. The only discernible difference is that it allows you to use hand-to-object grab interaction mode. If an object is set with hand-to-object mode, the hand will move to the object as opposed to the object to the hand. As the player begins moving the controller, the hand will slyly and covertly go back to the original controller position. It's recommended to use this mode with most medium-sized objects and above, as it often feels more realistic and avoids sudden jumps and movements when the player grabs an object. To make an object grabbable, go through the following steps. Select your object and add a rigid body if it doesn't have one already. Set the rigid body's mass to a realistic value in the unit of kilograms. If you want to make a static object, such as a wall or ledge that the player can grab, no rigid body is needed. In addition, add an AVR grabbable script. Optionally, you can select an object type. There are several pre-configured object types that you can see if you press the eye icon on the top right. If you don't select an object type, default values will be used. Note that only colliders that are convex can be grabbed. You can make concave objects grabbable by approximating their shape using multiple convex colliders. The colliders can be located in child objects as well. You can do this using the Unity editor itself, your preferred 3D modeling program, or a third-party asset. Myself, I can recommend Techni Collider Creator by Triangular Pixels, but there are other free of charge alternatives available as well. The Phys package comes with 6 pre-configured grab types. You can also create your own grab types by creating a new object, ArcVR, Phys, grabbable object type. You have a series of follow types which determine the object's behavior when it's being grabbed. The most common type, free, will make the object try to follow your hand. This is what you want to use when you want objects to be grabbable and movable with ease. The static type is for objects you can't move at all, such as walls or ledges that you want the player to still be able to interact with. The constrained type is for objects which have exterior physics forces applied to them, such as if they are attached to a rope or a spring. It is not always realistic to make objects fully grabbable and liftable. For objects that are meant to feel heavier, the heavy mode is intended. This will let players apply force to an object without fully grabbing it. You can also enable hand-to-object mode under your grabbable object type, allow or disallow an object to be grabbed with 2 hands, as well as change the object type when it's being grabbed with 2 hands. For instance, you might have an object set as heavy for 1 hand, but act as a lighter prop when it's being grabbed with 2 hands. The lightness and angular lightness values will make an object generally feel heavier or clunkier to move around when they are low. The break grab distance determines how far the actual controller must be from its virtual counterpart before the grab is broken. The heavy force multiplier can make the effects of the heavy follow type feel more pronounced. If you want to set up your own model for the hand interactor module, you will have to set a transform that corresponds to each tip of each finger. Additionally, you will need to have a closing/grabbing animation for each of the fingers separately. Correspondingly, they should be called proc underscore and the name of the finger. Set your animation layers to be like so. If you're having doubts, simply look at how the default hand interactor is constructed and replicate that with your own model. Some objects are meant to be grabbed in specific ways, like the handle of a mug or briefcase. To ensure the hand interactor applies a realistic pose, you can use grab nodes. To create a grab node, select your grabbable object and click on Add Grab Node. Alternatively, you can simply add a child object with an AVR grab node script. Move the grab node to the desired position, in our case the handle, you can press Draw Debug Hand to display what a grab on this node would look like. Adjust the rotation by simply changing the rotation of the transform that has the AVR grab node script attached. You can set the pose of the individual fingers by adjusting the sliders on the grab node script. You can set certain intervals for rotation depending on where the node is being grabbed from. For this, set the allowed pitch, yaw, and roll values, which represents the angle from the specific direction. You can test the individual angles by using the yaw, pitch, roll test sliders. The override radius property determines the distance at which the node overrides a regular grab. A grab performed at this radius will result in the pose given by the node.